All right, welcome back, AP Environmental Science. We're going to start talking about global climate change. I said that I'd keep every video under 10 minutes, and I think I'm doing a great job so far. So, good. Okay, we're going to talk about global climate change. Here's a fun little comic for you. It's settled. We agree to sign a pledge to hold another meeting to consider changing course at a date yet to be determined. That's kind of how it feels, right? When we talk about really solving climate change, this is kind of what keeps happening, right? They get together and they say, okay, we all agree that we need to do something. So next time we meet, let's talk about what we might do later. It just doesn't seem like it's solved. All right, so we're going to look at these three circles, or ovals really, and talk about the global change all the way down to the smaller circle of global warming, okay? So global change is planetary scale changes in Earth systems. This is land, air, life, soil, atmosphere. These are global changes, okay? Big changes on Earth. Global climate change is where we're just looking at changes of temperature, precipitation, storms, winds, currents, that kind of stuff. Global warming is just an increase in average temperature over time, okay? Now this is important. When people talk about climate change, when it was first being discussed, when the first science started to come out, everybody referred to it as global warming. And the reason it's called global warming is because the average temperature on Earth will warm. It's going to increase. But then there's areas in the world where the temperatures are going down, and people say, hey, I got a snowball today. So there's no global warming. The problem with that thinking is we're not looking at the whole system. When you only look at, say, one city, you're not going to be able to find global warming, because global warming is overall everything. It encompasses everything in the world. So all of these have natural and anthropogenic causes. Natural, of course, being natural, things that happen on Earth regularly. Anthropogenic being human caused. So the IPCC was put together in 1988. They gathered by the UN. The UN gathered with 3,000 scientists, and it's the Intergovernmental Panel on Climate Change. They gathered in 1988 for the first time. And they solved climate change. That's the end of the notes. No, I'm just kidding. I'm sorry. So we look at carbon dioxide concentrations, and we can see increases in those concentrations. I am going to have a video. The video after this is actually going to be all about the Mauna Loa Observatory and all of this. And some of it's going to be a review, but it's going to be there. So I'm not going to dig into the details of this because I don't really want to. This date right here, you can see 2020. That was the last time I updated this slide. I'm going to update in that video. It'll be as of 2021. And then, of course, if you're watching this in 2026 because Mr. Cope decided to get lazy and stop recording videos new every year because, that's a lot of work, you can look this up online. Okay, so it's called a Keeling curve, and it began in 1958. The reason it began in 1958 is not because, that's when global warming started, and that's when carbon dioxide started being a problem. No, it's just because that's when we started reading it. So this was the first time that they tried to accurately measure CO2, and what they found was that CO2 levels actually will vary seasonally, but they are increasing overall. So every little rise and dip is a seasonal change, but you can see that the overall curve, since they started getting this, is an increase in carbon dioxide in the atmosphere, and these are measured in parts per million. Remember that number, 417, that was April 16, 2020. You should be excited. The next video I'm going to show you what it is today, which is February 15th, 2021. So why is there a seasonal fluctuation? Well, because that's what happens, right? It's all a vegetation thing. Most of the vegetation, if you look at the map, the equator is right around here, right here, right about here. Most of the vegetation on Earth is in the northern hemisphere. And what that means is that overall, we're going to have a huge decrease in carbon dioxide in the spring and summer in the northern hemisphere because there's more vegetation to absorb that carbon dioxide. But of course, then when the fall and the winter come, you're going to see the rise of CO2. So just remember that. That's where that fluctuation comes from. We'll talk about that in the next video too. Why is there a latitudinal difference? Well, 90% of the world's population is in the northern hemisphere. So if we do just by population, that's where people live. This isn't based on population. 67% of the world's land is in the northern hemisphere. But phytoplankton actually produce more than 40% of the world's oxygen. So it kind of balances some of that out. The phytoplankton out in the water, also referred to as algae, right? Single-celled algae. That's where most of the oxygen comes from. So why does it increase overall? Well, that's just because we've had an increased amount of emissions from fossil fuel combustion and a net destruction of vegetation. We are decreasing the amount of vegetation in the world and increasing the amount of fossil fuels and the amount of carbon dioxide that we're releasing into the atmosphere. So it's a double whammy. So in 2009, developing countries overtook the developed in CO2 emissions. This is a problem. Not because us developed countries should be worried about the developing countries, actually because, well, that means that now it's not just the developed world's problem, right? We're not the only cause, which means we aren't going to be the only solution. The reason why? Well, it's all about that demographic transition. You guys remember the demographic transition way back when? Rewatch that video if you don't. The demographic transition is what causes countries to begin to transition to a more industrialized economy, which of course leads to more carbon dioxide being put into the atmosphere. So those developing countries are currently in those stages now, right in here, where things are going pretty well for them. So industrialization happens first. That's where you get more fossil fuel combustion. That's in stage 2. And then there's just not enough money or political will that's going to actually work towards passing these progressive environmental laws until phase 3 or 4. So in these first 2 stages, and more importantly in the first phase right here, where you have the industrial transition, where countries are starting to burn more fossil fuels, there's not really a whole lot of political will or necessity or, consideration of the consequences in those countries, whereas countries that are in, say, number 3, number 4, or even post, those countries are starting to say, hey, you know what? We should probably solve this because it's becoming a problem. These countries are literally just trying to do something. They're trying to get to the point where they can be sustainable. And that means that they're not worried about the consequences. Temperature increases are another big factor to this whole thing. Global temperatures have increased on average 1.4 degrees Fahrenheit, but there are certain regions where the average temperatures have risen as much as 4 degrees Fahrenheit. So this is a nice little graph here. The quote says, breaking the 1 degree Celsius barrier. The average global temperature in degrees Celsius changed since 1850 to 1900. So we can see right here, everything stayed at right around 0 change. We broke the barrier in 2015. We have now hit the 1 degree Celsius. The problem is, the scientists say that the no turn back zone is 2. And so we're halfway there. And we're getting there faster than we were at the beginning. That's a problem. So this is a graph to show you between 1999 and 2008, the mean temperatures. And you can see that the mean temperatures worldwide are above 0. And you can see regionally, those areas are darker because they have a higher temperature. So you can see up here, much higher temperature changes in the Arctic zone than, say, if you live in the Antarctic zone, which you don't because no one does. Just looking at data from satellites, 45% of the northern ice caps have already melted. We've done it. We're doing it, and we keep doing it. So in 1979, here's what it looked like. In 2007, here's what it looked like. It's not great. It's not great. And I'm going to end the video here, but we'll talk more about global climate change in the next video. The next video is going to be all about that Mauna Loa CO2 graph that we were looking at, and then we'll pick back up here at changing species compositions.